Hello, good morning. Good morning once again. Am I audible, right?
Yes, sir.
Okay, so first today we'll discuss hashing part, then we'll solve some numerical. So let me share my screen. My screen is visible, right?
Yeah.
Okay,
Yes, it is.
okay. So today first we'll discuss hashing. So in database management system, when you want to retrieve some particular data, it become very inefficient to search all the index, right? And reach the desired data. So it's very inefficient, right? So in this situation, hashing come into the picture. So what is hashing? Hashing is an effective technique to calculate the direct location of a data record on the disk without the using data structure. Hashing uses the hash function with search key as parameters to generate the address of a data records. So in hashing, basically there is a bucket like this, and there is a hash function. And this is the search key value, right? This is the search key value. And this map to the bucket where actual data is present. So this hash function is a mapping functions that maps all the set search key k to the address where actual records are present. It is a function from search key to bucket address. So basically, this address to the bucket where actual data is present. So let me solve some problem that will be helpful. So suppose data is 10, 11, then 22, then 33, then 34, and 35, and like 46, right? And these are the search key value. The hash functions hx equal to x mod 10, right? So bucket, so this is the bucket, right? So it will contain 10 record, right? So like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So if you h of 10, what will be the h of 10? 10 mod 10, it will be 0, right? So 10 will this place 10. Then if you find the h of 11, then 11 mod 10, right? So this will be 1. So h of 11 will be placed in this place. If you put the as if you the address h of 22, then 22 mod 10, it will be 2, right? So then 22 h of 33, h of 33, so h of 33 will be 3, right? So this will place 33. H of 34, 4, right? So this will be plus 34. So age of 35 more 10, this will be 5, right? So this will plus 35, and age of 46 equal of 6, right? So this will be placed 46. Suppose you want to more insert more records, 39, right? So if you age of 39 mod 10 equal to 9, right? So this will place 39, right? Suppose you want to insert one more records, 45, right? So if you find the age of 45 equal to 5, so if you see in 5 bucket already one record is present, right? So uh, so so this situation is called collision, right? So how to handle this collision? There are two methods. One is closed hasing and another is open hasing. So if you closed hasing, we create another bucket, right? It's called overflow bucket. So if you uh, if you insert 45, we create one more bucket and we insert 45. So everyone understand how to handle the collision? Hello, am I audible, right?
Yeah, you're audible.
So how to handle the collision? Everyone got it?
Again.
Yeah.
No, why do we need to the function of hashing itself is to move all data into different buckets, right?
Yeah.
So when why are we really looking for uniqueness over there?
Because if you want to search some values, so suppose it is order of 1, right? In hasing. If you want to search the 35, if basically expansion is given x mod 10, right? So 35 mod 10 is 5. So you'll go directly to the this location. You will find this data. So if you want, means in indexing or in other techniques, in search is very inefficient, but that's why hasing comes. If you want to search order of 1 time, you got it. Hello.
Now, my question is, why do we need to really look into the uniqueness? Like, if it comes normally 35 and 45, both if you park under 5,
Yeah.
then what happens? Like, it will return two values.
Yeah, it will return to values. Then this situation is called collision. So how to handle this collision? So basically in closed hasing, there are two methods: closed hasing and open hasing. In closed hasing, what we can do, we create another buckets in 5s and we placed 45s. In one bucket, only one data is one data record contents. So we create another buckets and it will link to the 45.
Okay.
Yeah. So in everyone got it. Then another is open. How to handle another method, open hasing. So in open hasing, linear programming is come. So linear programming. So what will do? Basically, it will move to the next six available in 6 position is available or not. It's not available. Then it is moved to the next 7 position is available. We placed 45 here. So basically in linear programming, let me draw. 0, 10, then 1, 11, 22 to 33. 44, 35, 535, 46. So in linear programming, a collision occurs in 35, right? So it will move to the next records. Then you will see it is blank or not, it is available or not, it is not available. Then it is moved to the next record. You can see that 7 is available, so it will insert to the 45 in linear programming. So everyone got it?
Sir, but how does the program know that it has kept it at that position?
Uh,
Set.
So you can see that every packet can contains only one record, right? So if it will see that 6 is available on 46, if it is blank, then it is insert the 45. If it is not blank, then it will search for the next packet 7. If it is available, then insert like that.
Sir, suppose it's searching for 45. How does it happen?
Okay, suppose 45, so it will 45 more 10, right? So it will 5. First we'll go to the 45, so it is not available in the 35. Then it will the move to the next pointer, move to the next 46. It is available not, then it will move to the next. So it is available in linear programming.
So then both the approaches, it's becoming like linear search, right?
Yeah, no. Uh, and you can see that in closed async, first it will go to the 5, then it will search the records. But yeah, some means up to the time means it becomes linear search. But suppose see if you search in the closed async, so it will move to the 5. So all the records are eliminated, right? So you can see that this in 5 will be present 45, 35, and 45 in closed async. But in linear programming, you will see the first 5. Then we know that data is record, the next record, or the next record. Then it will move to the next. Then it will move to the next.
Okay.
So you got it, everyone? Okay. So in their professor on given an example, so I'll solve. So in the instructors, in the instructor table, so instructor table.
Yeah, excuse me, just one moment. Hello?
Yeah.
Now you will be basically inserting records one by one into the buckets, right?
Yeah.
Yeah. Now this 45 came and inserted into say after 5, if it has to get inserted into next one, and by that time this 46 might not have come into picture at all. No?
Yeah. So basically,
like I'll go and insert 10, then 11, then 22. Like that, I'll keep on putting into the bucket. Now, said 35 came, then 45 came, then 46 came. Okay. So in that case, as per open hashing, 45 will go to the 6th slot, because that 6th slot will be empty that time.
Right? Yes. Okay. So
but when 46 comes, then it cannot be inserted over there. Then into that 6.
Okay. See. Okay. Let me give an example. So when I see. suppose they are given 11, then 12, then 35, then 45, and beyond to 46, right? This, if you insert, okay, so I hope you will understand this example. So 0, 1, 12, 2, 3, 4, 5, 6, and 7. So 11 will insert here, 12 will insert 35, will insert 35, then 45 will in linear programming. Forty-five will insert if that bucket is not available. 45 will insert in that bucket. Then if you insert 46, it will go to the sixth position, right? So you can say that this position is not empty. It will go to the next bucket, right? So you got it.
Sir,
Hello?
you are taking the mod with mod 10.
Yeah, I'm taking mod 10. A hashing function is x mod 10. This is,
Yeah, and that 0, 1, 2, like whatever you are writing, that one, right?
yeah. So if you, so what are the maximum contents? 10 record, right?
10 records, yes.
Yeah, yes, 10 buckets. So so uh, so it means how to handle the collision in linear programming. So that's I am explaining.
So here you have written 0, 1, 2, 2, 3, 4. Like, is it a
Okay,
typing?
sorry. No, sorry. This is typing mistake.
Okay. It's a typing mistake. Anyway.
Yeah. Okay.
So
And
then
in
12, why it is coming to 2, sir? 12 is 1 dot, like 1, right?
yeah, so
No,
12 mod
10 is 2.
Yeah.
That is, okay, understood.
Yeah.
Okay.
And yeah. And in syllabus it closed as
Now, how will we how will we decide which hash function to use? That will be a critical activity. Now, suppose we are given some 20 data points, then which hash function, how to find that?
Yeah, so it will be very it will be difficult to. That's why in extensible hashing or dynamic hashing comes. So it will be very easy in dynamic hashing. So that's why we read dynamic hashing or extensible hashing. So yeah. Now how to handle in linear programming is not there in syllabus. Syllabus is then closed hashing. So
So, sir, like question, like say for example 35, okay?
yeah.
35, like ideally it should go to 3, right?
No, 35 more than.
Sorry. I'm just taking the question. That's okay. Sorry.
Okay. So in closed hashing, let me remove the. So closed hashing is very important. Is it is in the syllabus? How to handle the collision. So add 0. Eleven will insert in this position. 12 will insert in this position. 35 more than will insert in the position. 46. Then 45 comes, right? So there collision occurs. So how to handle this collision? So it create one bucket in 5 and it link to that bucket and insert in the 45 and then 46. Like if another records like 55 comes, so 55 more 10 5, right? So we create another buckets and 55 plus there in closed hashing. So you got it, everyone got it, how to handle collision.
Yes.
Okay.
So sir, like characteristics of a good hash function is then like how uniformly it can distribute this
Yeah.
collision, right?
Yeah, right. So basically, if you if it is skewed, or it is means all has functions placed in a one's key values, then it will be means bad hash function.
Mhm.
Suppose all the records in the one, it will be the bad hash function.
Mhm.
Yeah, so then hash indexes. Hash index is like similar to hashing. So it will the search key. It contains search key and the pointers. Sorry. Search key, suppose 11, 12, 11, 12, 35, and 45, and 46. And this is the mod function, which is equal to hashing function x mod 10. And this is the bucket, right? So 11 goes to there, right? So it will point to the dash phone. 12 right there, so it will point to the that. 35 it will go to there, so 35 point to the that point. So 45, so it will go to the that point, and 46 it goes to the this one. So everyone got it as indices.
Sir, how this is different than closed
Yeah,
hashing?
it is very similar. We basically introduce hash indices, so that basically contains hash key and the pointers. This is called
Correct.
hash indices.
Okay.
This is okay, nothing else is similar. Basically how we stores hash key and the pointers.
Yeah, but if you go to closed hashing, like
This is the this is a closed hashing, right? This is the closed hashing, and
correct.
basically this is the hash indices we kept search key and the pointers in the.
Yeah, just wanted to understand like what is the advantage or what is the gain that you are getting?
So basically, if it's content, then
It
if it is content hash indices, suppose if you want to search the suppose some key, so 11, so it will go to the directly to the 11. It will point to the where data is actually stored. In if you seen this you have to find the basically hash function, what are the values goes. Then suppose if you want to find the search the 11, so you have to find the 11 mod 10, then you will find 1, then it will go to the 1, and in this position you can you already pointed this where actually stored, so it will goes to the
okay.
this position.
So that means you are not computing the hash function at runtime, at least
Yeah.
only during insert.
Yeah.
Okay.
It's similar you can.
Mhm.
Okay, so now we'll now we'll see bitmap indexes. Okay.
And sir, like also like please explain that B plus T tree deletion. Okay.
Okay, so yeah, so B plus tree deletion, I think not in the syllabus. If you want to, I will explain in the next session, that will be better.
Okay. because it is it has been told that b plus 3 deletion, that time you need to merge, right?
Yeah, that will Mars.
Yeah, so that merging, like if you can give some like probably some corner cases, easy merge are okay.
Okay.
Like but some corner cases where, say for example, you are like merging with like other leaf other node.
Okay, yeah. Yeah, I got it. So I will explain in the in the next live session. That will
Next
be, I
class.
think,
Okay, okay.
yeah.
No problem.
So that will be better.
Okay, okay.
So in bitmap index, it is a special type of indexing built on a single key. So it is designed to fire query on multiple keys quickly. So bitmap indices used basically mm, bitmap technique. So I will go through one example that will be better.
Yeah, sir,
Suppose,
just like a little bit probably off. Okay,
yeah,
the question. The say for example, you have a table and you have a front end build up. Okay, now
yeah,
that front end knows that okay how I will go and get the data.
uh, uh,
Okay,
yeah,
so front end executes some kind of a query. Okay,
uh,
say
yeah,
select start from XYZ table. Now
yeah,
you created an index. Okay, so this
yes,
index is stored in another table, right?
yeah,
And the
yes,
leaf nodes will be pointing to this actual table.
yeah,
Okay,
yes,
now do you need to check? Do you need to change anything into your application program?
in application program, I think not, because uh, if you see the Postgres data, Postgres, it already by default already makes some indexes like I think B3 or B plus 3 indexes in Postgres. So
No, Postgres it uses hash indexes.
okay, sorry, has indexes. So by default, I think it does not test for application. It will if you call that we call if you run some call some run some queries. If you go to the Postgres, right, so it automatically.
Yeah, but my question is, do you need to change anything in the application program? Because in the application program, you write this query, select star from this table. Okay,
Yes,
now
yes,
you have created an index basically.
yes,
Okay, so this
No,
query will go
this
and get fired. Now, do you need?
let me explain it. I don't know your name. Let me just explain the way you have. It is something like when you decide the design of the database, that time you will decide the design of index also. Okay, and and it is purely into the database management system, the index and table, and an external query comes, and that query is given into the database management system, from where it decides which index to go and from where to pick up data.
Okay, so let me
So
ask the questions.
suppose you have created a table, say an employee table. While creating the table itself, you will define on which column what type of index you need to generate. Accordingly, the database engine will generate that index, and every time when the data gets changed, the index also will get changed.
No, this is one type of case. I can tell you another case where you do not create any index at the beginning of the application. Okay, because index will create a overhead. You will say, for example, come up with a schema which doesn't have any index. Now, as user started using it, data grows and user complains that okay, now in this search query, I have a performance issue. That time, whatever we generally do, we go and create some indexes on certain tables. Okay, that time we go and create. We do not create the index in advance. Now, your query in the front end, it was supposed to be designed to go to that particular table, say for example, employee. Now you have created an index. Now the query, do you need to change anything in the query, or you will still use that same query, but internally database management system will route it to the index and then come back, then give you the result.
That's what exactly I said. No, internally the database system will route into the index and do the needful, because index and those system does not have anything to do with the programming side at all. It is purely into the database management side.
Okay, so you are saying like whenever we create the index, like this is that DBMS will manage that internal routing.
Right.
Okay.
Thanks. And very good. So now we'll move to the bitmap
And
indexing.
one more point, you said the index will be created later.
Later, yeah.
That is not the practice normally. Normally the practice is we do create the index at the design level itself, because at the design level we need to decide what would be the kind of expectation we need to set, how long it is likely to grow. All these things is a part of design actually.
No, but like I can tell you, like enterprise applications, like enterprise application deployed in like companies like Bombardier or Mitsubishi. Okay, there we never create the index at the beginning because that will be over engineering. You never know which table will grow faster. That will be purely depends upon the usage of that application by that particular domain customer in that domain. Same application, if you put into another, say for example Johnson and Johnson, their usage will populate a different table, and the time you create index, like you are carrying with additional overheads, right? So I have seen like at least
I
more than
understand
like
that. It
dozens
is,
of the implementation where we do not create any index at the beginning.
that could be. That is basically change on the go. You
Correct.
won't be able to predict what will happen, so you keep on changing on the go. That
Yes.
happens. Yes.
Yeah.
So when index is getting created, the application side does not normally care about.
Perfect. Okay.
Okay, thanks. So yeah, now we'll understand bitmap indexing. Suppose there is a tables ID and the gender and the income level. And the records are 766. 58583. And the genders male, female, male, female. And the income level like L1, L2, L1, L4, and the L3. Right? So bitmax index, suppose if you want to find the bitmax indexes in gender column, means males, what are the, so for bitmax index, for if you want to find the male, so for male it will means those column present male, it will print the 1, other than this it will print the 0, right? This present male, right? So 1, female present, so 0, then
0
okay, then 0,
1 0.
yeah, 1 0, and the female will be right,
Just opposite of him.
yeah, 0 1 1
0 1.
0 1, right? So if you want to the income levels, so if you want to find the income level of L1, so L1 will be the 1, other than this
1 0
0
1 0 0.
1 0 0, and the L2 will be
0
0
1 0 1 0 0 0.
0, sorry, 0 1 0
0
then
0
0 0. L2 L3 will be
0 0 0 0 1.
yeah, and L4
Triple 0 1 0.
1 0, right? So this is how to generate the Bitcoin index. Suppose the query is find the um, female candidates who have income level L, right? So what will the query? Select start from suppose this is the table name is suppose A is from A where gender equal to
F and income level.
income level equal to uh, income level equal to suppose
L2.
L2, right? So how to retrieve this query actually? It will, if you see that female is 0 1 1 0, so 0 1 1 0 1, and the L2 level is 0 1 0 0 0. So so perform n operation. So 1 0 1 will 0 will be there, right? 0 0 0
0 0 1
1 0.
0.
You can see that it will fetch the 0 on this records, right? So this will be very efficient. This is the use of bitmap index.
So, sir, this bitmap index will be stored in another table, right?
Yeah, it will be stored in that.
Okay.
So suppose some column has low coordinate like this gender, only two values present, male, female, male. That this case that will be very helpful or useful.
Yeah. So it is only possible like for a kind of a categorical data, right?
Yeah, correct.
Correct.
And if you want to uh, suppose you want to find the female candidate who have income levels. If you want to find the female candidate or income level L2, right? So female candidate or income level L2. So just perform OR operation, right?
Or operation, yes.
Yeah. So sorry, it will fetch at this 0 0, this and this. So it will fetch 3 record, right? So this space, and this record will be fetched. So that's why that's how Bitmap index is worked. So everyone got it how Bitmap index is.
Yes, yes.
Okay. Okay, so now we'll solve some numerical B plus B tree. So consider a B tree with the following properties. Block size is 1024 bytes, key size is 16 bytes, and the record pointer size is 8 bytes. And the block pointers, let me solve on bitmaps index. That will be better. Okay. This consider a table food FID, FNAM, food type rating. There can be only be two types of food, dessert or soup. The following rating value is an integer in the range of 1 to 5. Let the bitmap indices for column food type and rating be given below. Food type 1010 and dessert 0101 for soup. Rating 0101 for 1, 0010 for 2, 0110 for 3, and 000 for 4, and 1000 for 5. In order to find the FNAM of an item that is a dessert with a rating 2, which of the following operation will be performed? So if
In
to
order to if rating
So I'll be waiting 1 minute. You can answer in the chat box.
Right. Name. अच्छा अच्छा 1010 rating to the left 10101 and rating 2 is 0110 and 0110.
Oh, let me explain. So question is, in order to find the appname on an item that is a desert with a rating of 2. So what will be the query? Select appname from food type, from food, right? Where food type equal to desert, and rating equal to 2, right? And rating equal to 2. So you have to find the food type. Food type for the desert Bitmap index is given on 1010, right? 1010, and for rating to 0010, 0010. So basically you have to find the AND operation between those. We can give an logical AND operation on 1010 and 0010. So everyone clear with this?
Yes, sir.
Hello. Okay. So let us let's solve this problem, right? Consider a B tree with the following properties: block size given 1024 bytes, keep size given 16 bytes, and record pointer size given as 8 bytes, and the block pointer size given as 8 bytes. You have to find out the maximum order possible for the B tree from the given information. Yes, so I'll be waiting 1-2 minutes. You can solve, then I will be solved. You can answer in the chat box. Okay, let me solve this question. So what is the B plus B tree structure? Anyone remember? So this is the block pointers, then the key and the record pointer, right? Then this is the block pointers, and this is the key and the record pointer, right? This. Then another block pointers, and the key and the record pointers, and another record block pointer, right? So suppose order P. So block pointer will be number of block pointers equal to P, and numbers of key is be P minus 1, and numbers of record pointer will be P minus 1, right? So block size given 10245 bytes, 10245 bytes given, key size 16 bytes. So if you see the equation, suppose block pointers into P plus record pointers P minus 1 plus key P minus 1 less than equal to 1024 bytes. This equation, everyone got it? How this equation come?
Yes, sir.
Okay. So block pointer size is 8 bytes, right? So 8 into P plus record pointer size is 8 bytes. So 8 into P minus 1 plus key size is 16, right? So 16 P minus 1 less than equal to 1024 bytes. So 8P plus 8P minus 1 plus 6, sorry, 8. 16P minus 16 less than equal to 1024. So let's, so what will be the 8 plus 8, 16. So 32P. P less than equal to 1024 minus 24, right? So anyone solve this problem? So what is the value? Hello?
Sir, roughly 30, sir.
Okay, so roughly so block pointer is orders maximum order possible space P.
Sir, basically these block pointers are there to point the next leaf node, right?
Yeah, next step.
So in these why you are writing so many block pointers? Block pointers, like it seems like in the video, like whatever I understood is there is only one block pointer at the end.
In B, this is a B tree, right? B plus tree.
Okay, B tree. Okay, B tree, like so many block pointers, but B
Yeah,
plus tree only one block pointer.
yeah.
Okay.
So no, don't confuse the B tree and B plus.
Okay.
Okay. Yes, okay, so
Sir,
next question.
for B plus tree, we would have these block pointers in the leaf node, right?
Yeah, leaf node.
So in case of a B plus tree, like there will be only one block pointer, right?
Yeah.
One or two,
So,
because we both the side.
so yeah, in B plus tree, you see the sorry. If you see the structure in B plus tree, so you can see the in B tree such key value make key value and corresponding to the record pointer, right? But in B plus tree, record pointers means where actually data is present on leaf node. So in B plus tree, only such key value present and the block pointer will be present. And the block pointer will be present and the block pointer will be present. This is the structure of non-leaf node. And leaf node key value and the where data is actually present, record pointers like this. Then key value and the record pointer where actually present. And the end of the date is point to go to the next leaf node. It point to the next. We have explained in previous live session B tree and B plus tree. You can see. This is a very simple question. So I will be waiting 1 minute. You can answer in the chat box. Okay, so given B tree order 17, so order P equal to 70, right? So minimum numbers of child node will be minimum number of child node. Child node pointer.
Yes, ceiling of 17 by 2.
Yeah, P by 2. So it will be given approx 9.
9.
Yeah, and the minimum numbers of keys will be
8.
yeah, equal to n minus 1 by 2 equal to 8. So I hope everyone got it. Okay, so we'll move to the next question. So this is the bit tricky question. Consider a bit tree of order 3. If we have 9 elements to be inserted into the tree, then what will be the maximum numbers of split that taken place in the nodes? So I will be waiting 2-3 minutes. You can answer in the Zoom chat box.
Sir, split means?
Split means when B plus tree is splitting, right? So
Splitting
when
as
suppose there are order 2, right? Yeah, it means suppose there are 10, then there's 20. suppose order, then if you another elements is inserted, suppose 30, so it will be the split, right? So 20 will go over there, then 10, 20, and the 30. So this is the number of split is one, like that.
Sir, 3.
No, you try well. So there is one condition, when maximum numbers of split take place. What are the means when?
Maximum.
Yeah.
Yeah, I was considering minimum. Okay.
Okay. So anyone got the answer? Hello? Okay, so let me solve. Consider a b plus b. Consider a b plus. Uh, sorry. Consider b tree of order 3. If you have 9 elements to be inserted into the tree, then what will be the maximum numbers of split that have take place, right? So b tree order 3. So numbers of key can be present 2, right? N minus 1. So now one will be the maximum numbers of splits when the keys in decreasing or increasing orders. So let's first that's means increasing order. So let 9 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, right? So when you insert 1 and 2, so it will write that 1, then 2. When we'll insert 3, it will split, right? When you insert 3, so it will split. So then what will happen? 2, then 1, then 3. Everyone got it, right? Hello?
Yes, sir.
So numbers of, let's write numbers of split. Numbers of split 1, right? Now finally insert 4, right? So if you will insert 4, so what will happen? 2, then 1, then 3, then 4, right? While we'll insert 5, so it will split, right? It will split. 4 will go up, right? So what will happen? 2, 4, then 1, then 3, then 4. Sorry, 5. So number of sub split is 2. Here 1 split, right? Now when we insert 6, so it will insert it like this. When we insert 7, so it will be split up. 6 split up, 1 split, and the 4 if it is plus, then 4 against split up, right? So there are 2 splits. So it will write that 4, then 2, then there will be 6, right? Then 1, then 3, then 6, then 7. So numbers of splits 3 and the 4. Everyone got it up to this? How this comes from this?
Yes, sir.
Okay. Yeah. So someone answered 5. It's good. It's correct. Then when you insert 8, so it will be inserted in this position, right? While we will insert 9, right? So 9, so you have to split up, right? So 8 will go there. So let me erase. So what will happen? 4, then 2, then 6, 8, then 1, 3, then 5, 7 and the 9. So numbers of split taken is 5. So everyone got it? This question. Hello.
Yes, sir, it's clear.
Okay. So now we'll see dynamic as right. So let me stop the sharing. Any doubt in this question? Hello.
No, sir, it's clear.
Okay. Okay. Let me stop the sharing. Any doubt in the activity question or the practice question and week 9? Any doubt? Okay, so let me go to the dynamic as.
So just one thing I had to ask.
Yeah.
So means these are implemented. How are these implemented in memory? These structure B plus B tree, B plus tree.
B plus to B tree, right? Hello.
Yes.
So basically, in 9.3 we have also discussed in the if you in the previous live session you were present there or no?
No, sir. But sir means I'm
Previous live.
asking, like in terms of how does it's written in C, right? Databases and all.
So see, in DBMS, let me share the screen. That will be.
So this you can answer it after the session also.
Oh, okay. So I'll quickly go through the dynamic assay. So what are the disadvantages of the static guessing? So it is very difficult to find suitable hash function, and the when database will grow or shrink, it is very difficult to manage the. If suppose if initially bucket is too small and file grows externally, so then it will be very difficult. Or it will be very difficult, right? So for that dynamic hashing come, so it will very helpful for database for growth, sync and size. So basically in static hashing we 32-bit integers, we converted the hash function in 32-bit integer, and the length of the preface would be less than 32, 0 greater than 0 and less than 32, and the bucket addressable size it will be the 2 to the power I, initially I equal to 0. Okay, so basically I will build one example that will be better. Okay, so it is given as department name, so and in the hash function hash value is given in the 32 bits, and the given like this 00101101 in 32 bit. It is given in the. So now initially hash structure and bucket size is 2. So it all every bucket can contain 2 record, right? So initially 0 value, sorry, and the bucket size can 2 record size. Suppose if you want to insert Mozart, right? So if you insert Mozart is music department, you can say that in music department we take only prefix, right? So 0, right? Insert Mozart. So insert Mozart, and then this will insert Mozart, right? Then Srinivas is insert. So Srinivas is computer science. You can see that computer science on. So yeah, it will be inserted in the that when you insert W, so W record. So W record is this. So bucket is full, right? Hello. Only insert 2 records. Bucket is full. So you have to split up, right? So how to split? We can insert the this value, right? So we can insert 0 and the 1. You can see that computer science prefix value is 1. So Srinivasan will be recorded in this record. And the finance department, you can the prefix is 1. So it will be kept in this record. And the music prefix value is 0. So it will be inserted in this record, right? And the numbers of what is this? Numbers of bit required to distinct, right? So 1 bit required to distinct the two things, means you can distinguish the values. So we can say up to this is clear, right? Everyone, how to split up and how to insert the record. Hello, am I audible?
Yes, you're audible, Jiten.
Okay, so up to this is clear. Now insert Einstein record, right? So Einstein is physics, right? And the physics value is 1, right? So 1 bucket is already full, right? So you have to split up, right, in this value. So this is right, 0 0 0 1 1 0 1 1. So then now prefix will be 2 bits. We will be use that 2 bits, right? So we can insert suppose 1 0 1 0. You can see that finance 1 0, and the physics is 1 0. It will be kept in this bucket, right? And the computer science is 1 1, right? You can see the 1 prefix 1 1, right? And the music is 0 0. So you can see that only 1 bit can you can use this. So this will be 1. You can say that 1 0 and 1 1. So this 2 bits required to identify. So that's why it is written as 2, right? Now suppose if you want to insert gold, right? So gold is gold. You can see that gold is physics, and physics is 1 0, and physics is 1 0. So already is full. So you have to split up the this. So if you split up, you can see that. So let me write this. That will be very helpful. So you can see that musics will be right. So you can identify only 1 bits. So that's why written as 1. And the you can see that physics Einstein's. So we can say that you require 3 bits to identify this record. We can use 3 bits. Now you can see that also finance. See finance, and the you can see that music Physics value is 100, and we use 3 records, right? And the finance value is 101. So you have to record 3 bits, right? You cannot identify physics and finance, so that's why requires 3 bits. And the computer science history, you can see that 110 and the 11. So with the help of 2 bits, we can identify the among other cell. So you can insert this record like this. So you have to insert like this, and if database grows, you have to split it up like this. This is the advantage of extensible hashing. So everyone got it? Extensible hashing, how to insert the values and how to extend the prefix value.
Yes, yes.
Okay.
No, sir. Can you repeat once more?
Okay. So let's me 1 second. So initially we kept prefix value 0, right? So 0. So insert Mozart and Mozart. If you insert Mozart, so Mozart is music department, right?
Yes.
So insert is Mozart. You can insert Mozart, and if you insert 3 records, it will be bucket full, right?
Yes.
Insert Mozart. Then you have to split up this. So it will be used 2 bits, right? Sorry, 0 and the 1 bit. Then you can see that music department prefix is in this table. Music department prefix is 0, right?
Yes, sir.
So it will be kept in this position. And the computer science department prefix is 1, right?
Yes, sir.
So it will be right, Srinivas computer science. And the finance department is also prefix with 1, so we can like this. Now if you insert Einstein record, right? If you insert Einstein record, so Einstein belongs to the physics department, right?
Yes, sir.
So you can see that this bucket is full. Its prefix bit is 1. So this bucket is full, right?
Yes, sir.
So you have to split up the this value has prefix value, bucket addressable size, right? So previously we are using 1 bits. Now we have to use 2 bits, right? So
Yes, sir.
if you use 2 bits, so if you use 2 bits, so what happens? 0 0 0 1 1 0 1 1. Now we have to see the 2 bits, right? So you can see that now again we have to insert all the records. After the splitting you have to insert all the records. So if you see the computer science, you have to see the 2 bits, right? Computer science 1 1 3. So you have to keep this plus, and the Einstein's and the finance is also 1 0. So that will be kept in this plus, and you can see that music is also there. With the help of 1 bits, we can distinct the music. So that's why this plus, and this is the 1 bits. That's why and this way we will insert the extensible hashing.
So how is that department table that generated the values? Binary values?
It is given. It will be given, or it is given in the textbook, or if you want to some access value also. Suppose if you want to insert like this, suppose let me give one example. Suppose if you want to 1 2 3 4 like insert, we can generate binary value and it's converted into 32 bits, and you can insert that way, or you can use the prefix also or the suffix also. That's in this position also you can insert it.
Sir,
You can-
there are means
Yeah.
four means there are more than one value associated with the department. Is it like something like that? Means 001. If you check the biology first one, it's
Yeah.
given 0010, and then there's a space in between.
So yeah, it will return as 4 bits, 4 bits, right? Sorry, 4 for distinguish, nothing else.
Okay.
So everyone clear with extensible hashing? Okay. So anyone any doubt? Okay. Let me solve one problem. My screen is visible. Hello.
Yes.
So we can solve this. I will be waiting few minutes. Then I will be solved. You can answer in the chat box also.
So sir, we need to consider B tree or B plus tree here.
You have given the sparse indexing, right? Sparse indexing using the primary key. Not you have to not use B tree or B plus tree. You have to only sparse indexing. Sparse indexing using the primary key. So anyone find what is the answer? Okay, so let me solve. Am I audible, right?
Yes.
Okay,
Yes, yes.
so numbers of records is 2 to the power 30, and the block size is 1024 bytes, and the record size is 32 bytes. Primary key field of the record is 20 bytes, and the block pointer size is 12 bytes. We create the Sparse index file using the primary key, right? So what is the minimum numbers of block required for an index file? So first we have to find the blocking factors. Or numbers of records accommodate in block, right? So blocking factor will be, the block size is 1024 bytes, right? So 1024, and the record size is 32 bytes, right? So in one blocks, how many records can accommodate, right? So you can 2 to the power 10 by 2 to the power 5. So it will be 2 to the power 5, right? This is for main file, right? Blocking factor. Everyone got it? After this,
Yes, yes.
okay. The numbers of block required for mail files. We take this is the, sorry, means this value, right? Not ceiling value. We take floor value. Numbers of requires, numbers of block required for main file. In main file. So numbers of record is 2 to the power 30, right? 2 to the power 30, and one block content 2 to the power 5 data records, right? So 2 to the power 5, and those we take ceiling value, right? You can understand why we take ceiling value, because you have to require numbers of blocks, so you take ceiling value. In this case, in one blocks, how many records can be accommodated? So you have to take, suppose there is a one blocks, and block size is 10 bytes, and every record size is 4 bytes. So we take one floor and we take one port. So it can be accommodated 2 bytes. You cannot accommodate 3 bytes. That's why we take floor value. So everyone got it? Why we take this floor value? Hello.
Yes, sir.
Yes, sir. And the numbers of block required for main files, we have to take ceiling value. So we have to require, so 2 to the power 30 by 2 to the power 5. Okay. Okay. Now in the indexing, we have present search key value and the pointers, right? So this is 20, and this is 30, this is 12 bytes. In indexing, we use Sparse indexing, right? So numbers of blocking factor of for indexing file will be to the power 10 by 20 plus 12, right? So that will be to the power 5. This will take ceiling floor value. Everyone got it? After this is for indexing, blocking for indexing.
Yes.
Okay. Now numbers of block required for indexing file. Indexing file. will be to the power 25 by to the power 5, right? So this will take upper value. So this will be to the power 20. Everyone got it up to this? Okay. So any doubt in this question? Hello? So another problem. So this is the questions, and the question is so let me, okay. So this is the question. So you can answer in the chat box. What will be the answer? I'll be waiting 2 or 3 minutes. Okay, let me, anyone got answers? Hello. Am I audible?
Yes, sir.
Okay. So question is, consider a multi-level index with 4 levels L1, L2, L3, and L1 will be the innermost. So this is the L1 index. L1 index, so innermost levels, and after that L2 levels. This is the L1, and this is the L2, and this is the L3, and this is the L4. L4 is the outermost level. Let the index blocking factor or the maximum numbers of entries held by a block 50. So in one blocks, it maximum can be entries held by means can be 50 with the given information. So you have to find if the numbers of block in level 1 is 1 lakh, then how many blocks are required for L2, L3, and L4. So basically in that question given L1 is 1 lakh, then we have to find the L2 and L3 and L4. So in N1's blocks, numbers of block is 1 lakh, right? So numbers of block in L2 will be numbers of block L2 will be 1 lakh by 50. That's if to take ceiling value. We have given maximum can be 50. That so L2 will be 2000. So numbers of block in L2 is 2000. Now we have to find the numbers of block in L3. So numbers of block in L3 will be this by 50, right? 200 by 50. You have to take ceiling value. So 40, right? And the numbers of block in L4 will be L4 equal to 40 by 40. You have to take ceiling value. This will be 1. So this is the answer. Everyone got it?
Sir, why L4 should be 40 by 40?
Sorry, 40 by 50. Sorry, sorry, I have one mistake. 40 by 50, and we have to take ceiling value. That's why 1. So if you have any other doubt, if you have any doubt in practice assignment or activity question, you can ask. Otherwise, you can bind up the session. Okay. Thank you, everyone. Have a nice day.
Thank you, sir.
Thank you.
Thank you, sir.